So far, we've talked about how you can have an observational study or a design experiment. We talked about the different types of data you might collect, quantitative versus qualitative variables, etc. In this video, we're going to talk about how to decide which individuals you're going to include in your sample. And this is actually one of the most important points when you're ever trying to gather data, because if you take a bad sample, it doesn't matter how much time and energy you put into gathering your data, the data might be worthless. It might not tell you any important information if you have a bad sample. And to start off here, let's talk about the difference between convenience sampling versus random sampling. So convenience sampling, this is when you are going to choose individuals based on convenience. So let's say you want to take a survey of individuals and ask them about what type of movies they like, and you decide to go and stand outside of a movie theater, and whoever comes out, you start asking them, and you see whoever's willing to answer your questions. That would be a convenience sample. You're not trying to take a group of people that is representative of the population at all. You're just trying to say, I'm here right now. It's easy for me to ask these individuals, and the ones that are just choosing to respond, that's really easy for me. That would be a convenience sample. Sometimes that's the best you're going to get. Sometimes you really don't have any other option. And there are lots of examples out there where convenience sampling was used. However, for good statistics, you really don't want to use it if you can avoid it. It's much better to use some sort of a random sampling. And this is simply just you choose individuals based on some random procedure. And there are going to be variations on this random procedure that we're going to talk about in this video. But if you're using any type of randomness in order to decide who is going to be in your sample, that is going to be a random sampling method. Now, before we can actually get into picking these people, we're going to have to talk about what a frame is. So a frame is a listing of all individuals in the population. And it could be very easy to get a frame. It could be very difficult to get a frame. Here's an example that's not talking about, asking humans questions. Let's suppose your company got a shipment of 100 new computers, and you're trying to take a sample of them to see whether they're working well before you decide if you want to accept the shipment or reject it, send it back to the manufacturer. You don't want to take the time to test all 100 computers, so you can maybe test 3 of them and see if they're working. In that case, a frame is just the list of all 100 computers. That's a very easy thing. This computer 1, this computer 2, and so on up to computer 100. There's your frame. On the other hand, if I want a frame for the population of all individuals in the United States, it'd be pretty difficult to get that frame, right? To get access to a list of every single person that lives here, that's tough. If I want my population to be the students at Fullerton College, that would be a frame that is possible to get, but only for certain individuals. If you are someone in the right administration position, you could probably get a list of all the students at the college. However, if you're just some random person off the street, the college is very unlikely to give you that list, that frame. So again, frames could possibly be easy to get, they could possibly get difficult to get, but you really need some kind of frame, even if it's not a perfect frame, right? Maybe it only has most of the people. You need some kind of frame before you start getting into a random sampling. Now, the first type of random sampling we're going to talk about, and it's really the best, it's called the simple random sampling. And this is a sampling method where every group of the same size has the same chance to be selected. So let's say you want 3 computers out of those 100 to be picked for your sample. If you're doing simple random sampling, then any group of 3 computers is going to work. Okay, so that's simple random sampling, and again, that is the best mathematical method. It can be difficult to do because, again, you need your frame and you need to then select people randomly from your frame. But if you can make it work, that's going to be perfect. In fact, there are going to be formulas that we are going to see later on the semester that it's going to be assuming a simple random sample, because that makes the math really easy when all the groups have the exact same chance of being selected. But keep in mind that in a lot of real-world scenarios, it might be too difficult to do a true simple random sample. And so what that means is the formulas that we will have in this class may not work perfectly in those real-world scenarios. And if you were to go on and study statistics further than this class, you might see how they might modify those formulas based on, what is actually being done in that problem. So the second type of thing that we're going to do is called the stratified sample, or the stratified sampling method. So here's what we're going to do here. So stratified sampling is we break up the population into multiple groups called strata and obtain a simple random sample from each, and combine to make the full sample. So the idea here is that instead of trying to take a simple random sample of your whole population, you take your whole population, you break it up into different groups, and then these groups are smaller, and you're able to take a simple random sample from each one of them, combine them together, and that becomes your stratified sample. So maybe you decide to break up people in the US into 50 strata depending on which state they live in. You could break it up in that fashion and then take a simple random sample of each state. One benefit of that is that each state would have a list of everyone that lives in their state, possibly, but would not have a list of some other state. So each state individually could do their simple random sample on just their individual state. Then we can combine that together. Another example is you could take everyone in the U.S. and break it down by which party they choose to vote for, Democrat, Republican, Independent. You just need to break up your population in some groups and then take a simple random for each one of them. That's a stratified sample. Next up, we have systematic sampling. So this is, we put all individuals in some order, randomly select the first person, and then take every kth individual after, where K is chosen to break up the population into the given sample size. So, for example, let's say we had those 100 computers, and we want to pick, say, 4 of them this time. Then what we might do is we might say, okay, 100 divided by 4 is 25, so that K might be 25 in this case. and we'd say pick a random computer in the first 25. Let's say I pick, I don't know, 10. That's my random computer there. And then I add 25 to that and get computer 35. And then I add 25 to that, get computer 60. Add 25 to that, get computer 85. And those would be, so 10, 35, 60, 85. Those would be the 4 computers I use. So you just take your population, divide by your sample size to get like your K value. Just keep adding it on there, and then you're good. Notice that systematic sampling and stratified sampling are both not going to be the true simple random sampling because, for example, in stratified sampling, you're going to have groups from different strata, and it won't necessarily be, for example, a group of everyone in the same strata would not be possible because you're going to have some people in every possible different strata. There's no way that the subgroup or your sample of everyone from the same, let's say, state, California, would not be possible, whereas in a simple random sample, every group of the same size should have the same chance. Similarly, with systematic sampling, if you think about that computer example where we randomly pick 10 plus 25 plus 25 plus 25, every group that we pick is going to have exactly 1 in every group of 25 computers. There is no way to randomly pick 4 computers like 1, 2, 3, 4. And so that sample having no chance means it's not the same as other samples of 4 computers. Hence, it's not simple random sampling. So most scenarios that you deal with are not going to be truly simple random sampling. And that's just a fact of the matter. We can't really make that any better, but that's just how it is. The last one is called cluster sampling that we're going to talk about here. And so instead we're going to, again, break up the population into different groups. And previously we went to each group and said, give me a random people from your group and then go to the next group and so on. But instead, for cluster sampling, once we break up the population in a bunch of different groups, then randomly choose one group and take every individual in that group. So let's suppose you're interested in getting data from students at the college, do some sort of a survey or what that may be, and you don't want to try to go every single possible class and say, let's take 3 people. That'd be like a stratified sampling. You don't have a huge list to try to do a systematic sampling. So what you do instead is you say, okay, we got classes in all these rooms. I'm going to pick a room at random, walk in there, and do my survey. That would be a cluster sample, right? You're picking the room randomly, then asking everyone in that room for that data. That would be a cluster sampling. Now, I'm going to give you a little warning right now. Whichever teacher you walk in and try to do that is not going to be happy with you. You are likely going to be asked to leave, and if you persist, be kicked out. So don't think that you can just randomly walk into a classroom and ask that. I tell you this story because this actually happened with one of my students before. They wanted to do a survey, and they went off and walked in a random classroom and started asking for that, and got everyone in trouble. So please don't do that. But if you were, the idea of it, that's the cluster sampling. Just don't please actually do that at the school. I don't want to get in trouble again.